Hello, thank you very much for joining this session today. We're going to be talking about a technology for a circular economy for electric vehicle batteries. A quick overview of the agenda. My company is Everledger. We're a technology company. I'll be talking about the solutions that we have for industry, global initiatives around electric vehicle batteries, including the European Commission's proposed battery regulation. We'll talk about electric vehicle battery life cycle management and our platform for managing those life cycles. And that will include the battery life cycle itself, an exchange marketplace, which is a part of the platform, how we can establish and validate provenance of minerals from the mine, and greenhouse gas accounting throughout the supply chain and life cycles. So a little bit about Everledger. We like to call ourselves the digital transparency company. We were founded about 6 years ago by Leanne Kemp, and what her vision is to create greater transparency, trust, sustainability, as well as amazing customer experiences in marketplaces where product provenance and accountability matter most. Whoops. We have about 100 employees now globally, and we're headquartered in London. These are our other locations here, and you can see that this is our biggest location now is our remote employees, which are still scattered, unfortunately, everywhere. Our Australian colleagues have been fortunate to be able to work together. So let's talk about our industry solutions. Right now, we have a platform that we like to call, it's a blockchain-based platform, and I'll get into all the details on that, but we like to call it asset agnostic. So we can establish the origin of materials that go into the products that we buy and manage those products optimally throughout their life cycle. So right now, our platform is working for diamonds to prevent blood diamonds, gemstones, similar issues, wine and spirits, and luxury goods and apparel for authenticity and provenance of the materials that go into those products. Same thing with art, and then a little off the spectrum, electronics, and that today we'll be talking about electric vehicle batteries, but like I said, asset agnostic. So the platform, supports a number of benefits. So we create a digital twin of an asset and trace its journey on a secure and unalterable and private blockchain platform. And it's not just blockchain. Blockchain alone, it doesn't do much, but in conjunction with AI and many other IoT and many other technologies, it can accomplish amazing things. So it supports compliance and sustainability, helps manufacturers and product owners establish trust with their customers and suppliers, and also, as I said, creates transparency throughout. So here are, as I said, some of the technologies that support this transparency on the platform. So blockchain allows data to be recorded securely and unalterably as an asset moves along the supply chain and throughout its life cycles. So by converging this record with other technologies, we can create a unique digital identity for the asset. And then we use artificial intelligence, Internet of Things, that I'll get into a little bit more on another slide, connecting assets, items, things to the internet so that we can properly manage those, intelligent labeling, and also even nanotechnology. Nano-sized particles are finding more and more applications in object identification, and we aggregate those technologies to surface secure data about an asset. So let's talk about electric vehicle batteries. Many initiatives going on around the world. I'll just give you a quick overview. The Global Battery Alliance is a program of the World Economic Forum. They released a battery value chain roadmap about a year ago and introduced what they call the battery passport, what we call the battery passport in our solution, which is the digital ID for sustainable electric vehicle battery supply chain and life cycle management. So we're a technical advisory, and I'm also closely involved with all the activities of the steering committee. And right now, the Global Battery Alliance is incorporating provenance from the mine to validate that there are sustainable practices in terms of human rights and child labor for electric vehicle batteries, and also capturing greenhouse gas emissions throughout the supply chain and life cycles, and optimally managing those batteries throughout, and are looking at blockchain technology to support that. In the United Kingdom, they moved their ban on petrol car sales from 2035 to 2030. They just did that late last year. In the United States, the Department of Energy is supporting what they call the lithium-ion battery recycling prize. We submitted 2 applications in the first round. One was a circular economy for electric vehicle batteries, where we're partnered with Ford. And another one is closing the loop on portable lithium-ion batteries, which is developing an app that consumers can engage with to find location, to learn about portable lithium-ion battery recycling, to find a nearby location to recycle their battery, and to get rewarded for doing so. So we won a first phase prize, and for both of those, it's a 3-phase program. And we also progressed on to through phase 2 and into phase 3 with the portable one, and are progressing with Ford on the electric vehicle battery solution. In New Zealand, the Battery Industry Group has designed a product stewardship scheme for supported by blockchain that the industry is actually going to give to the government, or working with the government to create, to support a product stewardship legislation in New Zealand. And we are currently leading a pilot to support that with Audi. In Europe, the proposed battery regulation came out on December 10th of last year, and it includes extensive producer responsibility for electric vehicle batteries. And I'm going to get into that because there's so much involved in that, that's going to impact electric vehicle batteries and manufacturers. In Germany, Germany has a battery act. They require manufacturers to take back electric vehicle batteries or appoint a recycling partner. China took a big leap into this, probably a year and a half ago, with a mandatory electric vehicle battery producer responsibility and tracking scheme. And the Future Battery Industries Cooperative Research Center in Australia is establishing provenance from the mine for Australian mine critical metals and materials used in electric vehicle battery manufacturing. They want to create a clean energy future for Australia, and be producing lithium-ion batteries within Australia instead of just exporting the materials. And they also want to be able to brand Australian mined minerals as responsibly sourced and be able to validate that. So let's just talk about the European Union a little bit. Again, they announced the proposed battery regulation on December 10th. It's going to replace the battery directive, which came out in 2006 and only covers end of life of lithium-ion batteries, and includes the production and the use phases, all listed here. And it includes producer responsibility requirements, so that will add 26 countries to the current list of 2 that I'm aware of. Whoops. So this is right out of the proposed regulation, and what the green column is, what they call the medium level of ambition. Option 2. Option 3 is a high level of ambition. Option 4 is a very high level of ambition. And the green is what they anticipate will be implemented in phases 1 and 2 of the regulation going into effect. So there's the classification, a new category for electric vehicle batteries of and batteries with a weight limit of 5 kilograms to differentiate, large format batteries from portable lithium-ion batteries. And then it will require that at the end of first life, used batteries are considered waste. It will declare that they are waste, but repurposed batteries are considered as new products. So they have to comply with all the product requirements that a new product does when they're placed back on the market. A 65% collection target for portables in 2025. And to give you an idea of how high that is, in the United States right now, the Department of Energy estimates that our recycling rate is 5% for all lithium-ion batteries. That's really aggressive target. I'm not saying that that's what it is in Europe right now because you already have battery laws. New reporting system for automotive, EV, and industrial batteries. These are recycling content targets. So the first phase would be material recovery rates for cobalt, nickel, lead, and copper, and those are the percentages, and then increasing to higher levels in a second phase. And then carbon footprint for industrial batteries, carbon footprint declarations, information requirements on performance and durability, mandatory declaration levels for recycled content, and then specifications for extended producer responsibility obligations, and a minimum standards for producer responsibility organizations that support those laws. Obligations for removability, I'm almost done. Provisions of basic information, labels, technical documentation, and so forth. So these are all things that can be supported with technology, and the European Commission is looking at building an electronic platform to support all of this. So just quickly, a timeline, just to give you an idea. I pulled this out of the regulation. It's not really summarized in there, so I hope I don't have any mistakes here. But so the first thing will be this feasibility study for the electronic exchange system that I just mentioned. And then in 2022, it will enter into force on January 1st, 2022. And then some future dates for the duration and financial impact, the electronic exchange system, and other dates for implementation of the recycled content provisions and minimums and increases in those numbers. So let's talk about technology that can help ease some of these requirements that are coming into place globally. So what is a battery passport? I mentioned that earlier in terms of the Global Battery Alliance. It's really just the digital identity that connects the battery and critical parts to the internet. And it supports an exchange of data among authorized lifecycle stakeholders so we can support a sustainable value chain for electric vehicle batteries and stationary storage batteries. Traditionally, the way information flows is linear. And here, you can imagine when a battery is created, there's a lot of information about that battery, about what goes into it, about manufacturing, the bill of materials, what type of chemistry is it, and so on and so forth. But as that battery moves through all these stakeholders, that information gets diluted or lost, and information about new things that happen to that battery are not collected. With a blockchain platform, qualified stakeholders participating in that ecosystem can share permission data on the blockchain and have access to it in real time. The data is immutable, it cannot be changed, and it's extremely secure, and we call it permissioned because in a permission blockchain as opposed to a public blockchain like a Bitcoin, the users are known. So blockchain and AIDC, which is automatic information and data capture. So this is what connects things to the internet. And these icons here that you see represent QR codes and NFC and RFID and even digital DNA and Bluetooth and so on and so forth. So we like to work with as many, be able to access the information for the blockchain from as many technologies as possible, and work with manufacturers and with the type of labeling that they're already using, if that's possible. So what we're doing is basically taking an asset and connecting it to the internet so that we can learn more about it and take best care of that product. So for batteries, lots of challenges, but lots of opportunities. And the big challenge is data visibility. And we hear this from the stakeholders in the life cycle that you saw on that previous slide. So from the auto recyclers and from the garages and people that get these batteries, even the repurposers that, have to go by what their prospective customer tells them about the battery, not what they know about the battery. So we asked, we've done a number of surveys and asked what kind of data are these stakeholders looking for? And safety information obviously is paramount. Repair and disassembly instructions, service and repairing, whether it was in an accident, is the BMS data accessible? Have repurposing activities been properly executed? Has the battery title been transferred to the repurposer to relieve any potential liability on the OEM? Are replacement parts authentic? Have end-of-life materials been or batteries been responsibly managed? And what about critical metals? Do I have an accounting of those for recapture for manufacturing so I can support my recycled content claims? These are all really important, and they're all a part of the European Commission's proposed battery regulation. When we have all these stakeholders connected in a blockchain, sharing data, there are a lot of benefits. And this just represents some of the value that these stakeholders have expressed in this solution. So an electric vehicle OEM will say, we wanted to repurpose batteries before recycling, but we had liability concerns. Now we're more confident with transfer of the title on the blockchain. And an auto recycler might say, I now know what kind of battery I have and what my best options are for managing it. Before, I was turning electric vehicles away, and that is a fact. There are auto recyclers that are doing that. And a repurposer would say, with falling battery prices, it's essential that our process is efficient. We can now ensure we only buy batteries we can use and spend less time evaluating them. What happens way too often with repurposers is they get batteries that are not suitable for repurposing, and they have to go through a very high added expense of packaging and shipping and recycling those batteries that should have never been there in the first place. And the recyclers, whether they're just doing disassembly or they're doing the actual material recovery, would say sourcing electric vehicle batteries in this emerging industry used to be a challenge. Now we rely on the exchange to find out what we need and where, saving lots in transportation costs. And I'll touch on that in a moment. And then the battery manufacturers, it's important for us to secure a long-term supply of minerals for our products. Knowing that our batteries are being put to maximum use and being recovered after use helps ensure that. So what are the benefits? Regulatory compliance, knowing what type of battery it is, what condition that it's in, improved safety, ensuring batteries aren't sitting in storage, knowing the state of health, improved efficiency for repairs and refurbishment, and many, many other benefits. I mentioned the electric vehicle battery exchange, and I'll just go over that. So here, as a recycler, I want to be able to connect with clients who have batteries I'm able to recycle. So I want to be able to go into the exchange and, set and forget the type of batteries that I'm looking for, what condition. Well, actually, recycler doesn't care what condition they're in except for in terms of transportation. So auto recyclers will have batteries that need to be recycled, and they will be on the exchange. And garages will have batteries that cannot be repurposed and can find the recyclers on the exchange. And we'll be launching this in the first half of this year. As a repurposer, I want to be able to connect with clients who have batteries I'm able to dismantle and repurpose. So again, first I want to be able to set and forget on the exchange what kind of batteries I'm looking for and what condition that they need to be in. So again, auto recyclers and garages that have batteries that are, potentially suitable for a purpose can lodge that information on the platform and get connected with repurposers. And over here on the right is just, a huge list of data points that can be supported by the platform. So I'm going to play a little video here on how the lifecycle management platform can work, and we'll go ahead and run that now.
Today, Everledger is demonstrating how connecting electric vehicle batteries within a blockchain platform can optimize life cycles. Here's how data can be shared to improve safety, enhance efficiencies, and ensure responsible end-of-life material recovery. Logging in and accessing the dashboard provides at-a-glance battery information, and every participant in the network can have a customized view that's relevant to them. The Asset Vault helps to manage batteries and modules, and detailed information can be uncovered by clicking through to the Battery Passport, which shows general information about the battery, its chemistry, state of health, and more. This information can also be accessed by scanning an IoT device on that specific battery directly. Similarly, the Module Passport also gives more detailed information about the module. Batteries and modules can be transferred peer-to-peer between network participants via their registered email addresses. And in this way, the platform captures the chain of custody of battery and modules throughout their entire life cycle. When a battery reaches its end of life in an electric vehicle, the life of its module can continue. Here, a repurposer has the ability to disaggregate a battery and reuse the modules to create a new energy storage battery. In this way, we are still able to record the module's journey past its life as an EVB. The repurposer has the ability to create a new battery on the platform. In order to perform this function, they navigate to the Asset Vault. Here they can select previously disaggregated modules to design a new energy storage battery. By accessing the Create Battery screen, participants can simply insert the remaining battery attributes. Finally, with the details confirmed, a new digital battery is created on the blockchain, ensuring the complete journey is traced from its origin to the point of responsible recycling. Because at any point, when a new battery or module reaches the end of its life, it can be transferred directly to the recycler. Once received and processed, recyclers can lodge recycling evidence and data as an event on the platform, which can be shared with permissioned stakeholders. The secure sharing of information helps manage EVBs to final recovery and beyond, creating a circular economy for all electric vehicle batteries in the market.
Okay, so that really is phase one of the release of our electric vehicle battery platform, and the next release that we're working on is the provenance from the mine, and that will be later on this year. So here we're showing, what we can do is create a digital identity or a digital thumbprint. Our partner in that is Source Certain, and we're doing this in Australia for the Future Battery Industries Cooperative Research Center that I mentioned in Global Initiatives earlier. And so we can actually create a digital thumbprint of materials as they are mined and move throughout the supply chain. And you can see this little RFID icon here. Of course, we're not exactly using RFID, but other automatic ID technologies to be able to trace from the mine through the traders to the smelter. Even as that is transformed, we can use that thumbprint for forensic validation that the material going in is the same as the material coming out, and then into production and into the battery and even into the electric into the battery going into the electric vehicle. So that digital thumbprint can actually follow those minerals all the way into the vehicle. So we're really excited about this. And then for greenhouse gas accountability, this is also a part of the European Commission's proposed regulation and the work of the Global Battery Alliance that I mentioned earlier. But we're ensuring the credibility of sustainability across supply chains, improving data insights and standardization. And over here on the right, it's a little hard for me to see, but you can see how the platform is going to enable users to put in data with evidence on greenhouse gas emissions, and be able to do the calculations and even be able to use carbon offsets on the platform to offset the carbon that they're reporting. And that, again, is a future iteration, and probably late this year or early next year, we will have that component incorporated into all of our platforms. And that's all. Thank you all so much for attending. My colleague Esser will be taking questions, and I look forward to hearing from you. I can be reached at lauren@everledger.io. Thank you. Bye-bye.